Hi, everybody. Welcome to my session, Improvements about User-Defined Functions. You heard about that it's just only 30 minutes, so we have to hurry up. What I want to show you is what's new, not the basics about user-defined functions, but just only the brand new stuff about it. That's me. You know the commercial. Forget about this. Only important thing here is to mention my email address. That's a real address, not a fake address. So if you have any questions, feel free to drop me an email about this. So this is the basic agenda when I'm talking about user-defined functions, but unfortunately we have 30 minutes, so the basics are completely
we don't see your new slides. We just see the first slide. Yes, thank you.
Is it okay?
Yes, now we see.
It's my laptop because I just only have 4 cores and it's getting warm here. So what I'm taking very short is the different types of user-defined functions, problems with user-defined functions, and that is only demo-based. So we have 2 different types of user-defined functions. First is scalar functions. Scalar functions, long story short, they just only return a scalar value, and that means you can use this, for example, for an output in a table, in a select statement, which I don't recommend. You can use it in stored procedures, and you can use it in other functions. And the second one is the so-called table-valued functions. And the name, as it's in the name, table-valued functions mean that you don't return single values, but you return tables. The paradigm shift with SQL Server 2017 was tremendous. So that means before SQL Server 2017, the problem was that all the functions which are used, which have been used, that mean that they were executed once, and the problem was that was all with the same operators and the same memory grant. That was one of the biggest problems. In 2017, the first part of intelligent processing, query processing, came into the game called adaptive query processing. Most important thing here is that the user-defined function could be executed as part of the query during the execution plan creation. I will show it in detail inside the demos. And with SQL 2019, we had a very cool feature implemented. It's called Scala UDF inlining. And I will show you how it worked before and what the benefits of this new feature is. The problem in general with Scala function is that the output in a select statement can cause extreme heavy CPU and IO consumption. Another problem here is that when you execute a query and you have a user-defined function in the select, so in the output statement, you won't or you didn't see it in the execution plan, and you thought by yourself, hey, cool, my query is running fast because I see only a few operators. And another drawback of user-defined function was that when you use user-defined function in your query, in your views, in your stored procedures, they could not run in parallel. And that was one of the greatest drawbacks you could have with user-defined functions. So Microsoft said, let's go into Office, do some brainstorming, and let's see what we can do way better. So the problem with these Scala functions in general is iterative invocation. What does this mean? Well, when you have a select statement and you have inside or in your output a user-defined function that will be executed every single time when a new row gets fetched from SQL Server. And that is a tremendous workload. During optimization, only costs of relational operators gets calculated. And that's what I mentioned when I said to you that you don't see the costs of user-defined functions inside an execution plan. Interpreted execution, I think it's clear. We are all developers here. UDFs are evaluated as a batch of statements, executed statement by statement, and each statement itself is compiled and the compiled plan is cached. And as I said, serial execution, that was truly a drawback. So, however, forget about the PowerPoint. We go into the demo, and here I hope that you can see my management studio. And what I want to show you here is drawbacks and the benefits of Scala functions. So what I'm doing is I go into my demo database and I create two tables. The one is the customer, which has around 75,000 rows, and the customer orders with 3 million rows. For a better performance, I create two indexes. One is the clustered index on the customers for a better search argumentable, and the second one is on the customer ID and on the order date of the customer orders. So that's how it works so far. What I'm doing then is, because I want to show you the internals of how a Scala function is working, I create an X event which monitors the execution of the Scala function. So what I have here now, this is a stored procedure I've developed for me, is here track Scala functions. So there is no storage for that. You can only see this online, and I go into watch live data. So whenever I run now my stored procedures or my statements, I will see what happens. So next thing, because I'm working with SQL Server 2019, I want to make sure that the brand new feature of the Scala UDF inlining is disabled. Therefore, what I'm doing here is I disable this brand new feature because I do not expect everybody running a 2019 in production. Okay, here we go. Statistics, IO, and time should be on. And what I do first is I run a typical query, which is completely set-based. What means that we have here just only relational operations. The cross applies an inner join with a subquery. And what I'm doing here is I want to have for every customer larger or equal to 10, the number of orders for 2019. So let's execute this. And what I want to do here is I want to do this with an execution plan. Here is the statement. The result is okay. And see what SQL Server is doing. Long story short, we are aggregating the data from the customer orders. That is an index seek, which works perfectly. And then we come back with 10 rows, and SQL Server decided to use a nested loop. And then for every single row, we go into the customers table to fetch the name of the customer. At the end, there is a sort operation because I want to order it by name and the output to the client. Let's see what SQL Server did here. What you can see, this is something I don't want to see, just a second, please, come on, is here is my statement. And you see that the duration is 9 milliseconds. No CPU time and no IO because we had the data here in, in memory. So, and now I do the same with a bigger amount of customers. So with 1,000 customers, run the query, and you see here, it was very fast. And you see that the execution plan is nearby exactly the same. So SQL Server is seeking in the customer orders, coming back with 1,000 rows, and per each row we go into the customers. So far, okay. Here is the statement, and you see that it has slightly changed, not very much, but we used a little bit more of CPU time. So now we are developers, we love to develop. And what I do then is I say, oh my goodness, I want to have a function which will reflect exactly the information about how many orders a customer gets. So what I do is I create a function where I hand over the customer ID and the year for what I want to have the number of orders. So that is a simple statement. Go for it. Now I clear my data. And here is the brand new query. We'll look to this. It seems to be that it is exactly the same as it was before. We want to have the ID and the name of the customer, and then we want to get the calculation of the number of orders for every single customer. What I'm doing then here is with execution plan, I run this query, and I think that you have seen that it was taken a little bit longer than it did previously. It was around 1 second. And when I look into the execution plan, you might see, hey, come on, that looks absolutely brilliant. We just only have a clustered index, seek, brilliant. And then we have a sort, we come back with 10 rows. And then per each row, we go into the function and the result gets returned to the client. The biggest problem we have here is this. When you have a look to the execution, you see here perfectly what has happened. So the statement was starting. I started my select statement, and now look to this. 1, 2, 3, 4. I promise it's 10 times the execution of the function. The problem is here the duration. This is microseconds, 1 millisecond, 1.7 milliseconds, and in total it took 18 milliseconds for the execution. And one of the biggest problems a developer has when we are talking about it, if you look into the messages, you won't see this here. When you look to the I/O statistics, you will mention, or you would like to think, hey, come on, it's just only 3 I/Os. But it isn't, because a Scala function will not appear in the I/O statements or in the time statements because it is a compute Scala operator, which is not a relational operator. So in total, we have way more. We have 30 I/Os here on this part. And that makes it so dangerous from my point of view. And maybe you think, hey, come on, 10 rows, that's cool. I like it. And I see the benefits of a Scala function instead of using every single time this long text, which I need to develop. Think about it a little bit bigger. Let's say we want to have 1,000 rows. Let me clear the data, go for it, execute this. So it was 0 seconds, incredible fast. But the problem here is we come back with 1,000 rows, but here 1,000 times the call of the function. And keep in mind that a Scala function is always CPU bound. So you consume lots of I/O. When you as a developer will implement this, I promise you your best friend will be your DBA when they have to monitor why they have so many peaks in the CPU. Good. So Microsoft was becoming aware of it. And what did they do? They said, oh my goodness, we have to do something for that. In Germany, we say, ich habe da was für Sie, it's called Ratiofarm. Yeah. Okay. Here, Microsoft had a very cool thing in 2019, which called inline function, inline functioning. And you can see whether your function is possible to use inlining or not. So the only thing what you need to do is you run a query against this SQL modules, and then you see whether it is possible to have it, you can use it as an inline function or not. So my function here, you see, Microsoft determined that this function can be used as an inline function, what means that SQL Server will turn this function from a row-based operation into a set-based, so in a relational model. And now see what's going on. I set the Scala UDF inline on, and I run exactly the same query. Before I do this, I clear my data. Perfect, yeah. Clear my data, and it's working. It could be that it's incredible fast, and now see what SQL Server is doing. The plan has changed. Now you see that SQL Server will use the function here in this part at the bottom and say, well, okay, I see that it is a basic select statement, which means basic set-based operation. And then SQL Server will include this automatically in the plan that everything is now working set-based. And when I look to the live data, you can see here that SQL Server has no more call of the function. It will be handled as one single statement. The only drawback I see here so far is the problem with the nested loop. SQL Server will automatically, I don't know why, but it will automatically use a nested loop. So when I take the 1000 Go in here and you see again, SQL Server will use a nested loop. That is the only thing what concerns a little bit, but this behavior is way better than it is with a call of the function every single time. Oh, yeah, here it is. The only thing what SQL Server changed was now we are growing in parallel. That's okay so far, but it's using a nested loop. So this is one of the, from my point of view, great benefits you have with inline functions. Basic requirements are that you have to have a select statement in it. You can use if then else structures, and you have to have a return statement in your function. There are a few restrictions. You cannot use intrinsic functions. I think it's clear. Non-deterministic functions cannot be used. It's not allowed to have references to table variables, no order by, no user-defined types if you prefer to work with this, and you cannot use CTEs inside your Scala function. If you don't want to use automatic inlining, you can use a query hint. You say disable T-SQL Scala UDF inlining inside your statement as a option use hint, or what I did, I set it to off for the whole database. But I would strongly recommend not to do it that way. Try to use this super feature if you love to work with Scala functions. And only if you see drawbacks inside your statement, just use the use hint for this option. And another set is that you can switch to any other compatibility level than 2017. Multi-statement table functions. Oh my goodness, I had so much fun with it, and to be honest, that was the way how I earn my money, and that is the reason why you see this fancy card there behind me, because I see too often in development that developers are using multi-statement table functions, and I can precisely know understand why they are using that, because they want to make steps in between. Let's say you get a bunch of data, you want to do some calculations, and then you will put out the information after the calculation and want to join it with others. This is basically not working with a basic select statement. So that does mean that you need to have a function or a subquery in that. So multi-statement table functions are dangerous. For one simple reason, the estimated number of rows which returns back from these kind of functions. Here is a problem what I want to discuss with you. The wrong estimates are definitely the problem. You see here in the first line there is a basic statement. Select star from get order list, and the number you see inside is only the number of rows which should be returned to the customer. So to the client, sorry. If you are working with SQL Server 2012 or earlier, then the estimated rows were by default always 1. So whatever you wanted to have, SQL Server was always estimating, hey, come on, this is only 1 row. From 2014 to 2016, Microsoft has increased this estimated number from 1 to 100. To be honest, it doesn't work in an environment with a data warehouse, for example, where you're dealing with lots of data. So the problem was with these functions, even a recompile didn't work here. So whenever you were using multi-line table valued functions, to be honest, you were lost, or you definitely knew that you only have a small set of data which you want to work with. So let me show me how this problem works. So here is my database, and again I create a customers table, customer orders table, same process, and then I create my clustered index on it. I close this, that's perfect, come on, this can be closed too. And now I create another X event. This time I create it for multi-line UDFs, because with the multi-lines, there are so many changes which can only be seen when you trace that with X events. So what I'm doing is, I first of all, again, as with the Scala function, switch it off. That you can see how the system did work before 2017. Here is my query. It's really simple. Pardon?
Yes, now we can see your Management Studio. It wasn't visible before. Thank you.
It wasn't visible. Oh, sorry. But now it's working? Is it working, Conny?
Yes, it's working.
Okay, then I deactivate my camera. Maybe that's a little bit better. It's because we are living in the middle of Norway, and we are so happy that we have now 6 megabytes of in DSL rate. Sorry about that. So here I'm now creating my function. Very, very simple, but for demo, it's absolutely perfect. What I want to do is I create a table valued functions, get order list, and the only parameter I hand over is the number of rows I want to see. So then we put the data into a table variable, and afterwards we return it. You see that here is only a return statement, no return variable, because you don't need it. The definition of the output table has been defined right over here. Okay, here we go. This is my first query. And before I do this, I want to start my multi-line, watch live data. So, okay, nothing in. Here is my statement. And this is the behavior before 2017. And let me show you the execution plan. Here it goes. You see 1,000 rows. Now we go to the execution plan, and here comes the biggest problem we could have. You see here that SQL Server is running this function, and please have a look to the estimated number of rows. It is 100. Yeah. So that is definitely the key point. If I say, come on here, I want to have the number, the name of the customer and its order numbers for, let's say, 10 customers. Here comes the query. And now look to the execution plan, what SQL Server is doing. We know that we want to have only 100, or that we want to have 10, but SQL Server is thinking there are coming 100. 100 is not so problematic, but please have a look to the memory grant. The memory grant is because of the stop operator with the sort operation right over here. The problem with this is this here. Do not be afraid of this horrible X event, but let me explain what happens here. Here is my query. Let's see, one moment, insert into, come on, here, okay. What is important here? Please, first of all, have a look to the situation that in the first step, SQL Server compiles the query itself. And now think by yourself, when you first of all need to compile the original query, what do you know about the function? Nothing. So what you need to do in this case is you have to guess how many rows will this function return here. So that is the point. We think that it will be 100. In the next step here, you see that the table valued functions get executed. Here is my insert into. And now have a look to the execution plan. Here it is. And SQL Server thinks the estimated number of rows is 1,000, but please stop, go here. Here, the actual number is 10 times, but he was thinking, hey, we're coming back with 1,000 executions. This is absolutely not the right thing. And here, maybe here you can see it. Let me go for it here. Here then you see, oh, 5 minutes. I have to hurry up. Thank you. Okay, so here we come with this problem. We come in with 10. SQL Server was thinking 100. Okay, make it last time a little bit more difficult. I run this one, 10,000 rows. We are running that, we coming back with 10,000 rows and see what happens. We have a sort spill here. And the sort spill is because we were thinking that 100 rows coming back. You go with a knife to shooting, yeah? And here is exactly the problem, the memory grant. So Microsoft, again, was getting back in the office, thinking about what can we do, and said, hey, I have an idea. Using interleaved execution, I will clear my data, activate this option, and now I run this 1000 with the 1000. Have a look to the execution plan, look to the estimates. Yay, 1000! Exactly what we want. And if we go to the live data, you see that the trace entries are looking a little bit more complex. What SQL Server did here is that we, first of all, before we start the original execution of my query, we execute the function. So in that moment here, SQL Server definitely knew that we have 1000 rows. And afterwards, we are starting our original statement. And that gives a super, super great performance here. Let's do it with this one, with a 10. Go for it. Execution plan is thinking, well, we are coming back with 10. Very easy. And the estimates is 10 too. And here, I want to clear the data again, run it with 1000. So SQL Server definitely knew that we have more rows. If you look to the execution plan, SQL Server now knows, well, it's 1000 rows. And have a look to the statement. And it's really, really, really perfect. So first of all, we start our generic function, our multi-line function. And afterwards, we start with the original statement. The status will change. So let me see this here. Here it is. This is the most interesting part here, interleaved execution stats update. So SQL Server has executed the insert statement, and now it decides, hey, come on, I did a change. We do not have the guessed 100. No, we get 1000. And now with this information, the compile phase of my original query can happen. And that is absolutely super, super brilliant. So here it is again. You see here that SQL Server will now, first of all, execute the function. And then we come to the original query where at that moment we know the values. New extends are there. This we can stop. And here is a summary of all improvements in SQL Server user-defined functions. In 2009, we had the Scala optimization. In 2017, we had the multi-line optimization, and inline didn't change because they are always the best. Thank you very much for attending my session, and please feel free to ask any questions. We have 1 more minute to go.